All right, this one will be a little bit more challenging because of the way the root signs are all set up. But let's see how it goes. Why don't we start by getting rid of the root signs and changing it to a power of a half. That'll make it a little bit easier to do the derivative. So let's see what we have here. We know the derivative, how to do the derivative of something like this. We bring the half to the front. We ignore this. We do a half minus 1, which is negative 1/2. And then we multiply by the derivative of what we're ignoring. So we get something like this. Over here it's the same thing. The half comes to the front. We're ignoring the 3x this time. A half minus 1 is negative 1/2. And then we multiply by the derivative of what we were ignoring. Okay, why don't we see what happens here? You know, 4 over x to the negative 1/2, if I flip that, I can write to the positive 1/2. How about the derivative of 4 over x? Well, I think it's useful to remember the derivative of 1 over x. It's negative 1 over x squared, right? Maybe the way to remember how to do that is, this is really x to the negative 1. And then to do the derivative of x to the minus 1, just use the power rule. So it would be minus x to the minus 2. And that's the same thing as minus 1 over x squared. Now, if there's a 4 here, that doesn't change anything really. It just multiplies across. So the derivative of 4 over x is negative 4 over x squared. Now, if you're having trouble seeing that, I guess I can quickly do that for you. I just want to make sure you understand. Don't use quotient rule for that, okay? Just the way to do it would be like this. If you want to do the derivative of this, just write it as 4x to the minus 1. And then use the power rule. 4 times negative 1 is negative 4x to the minus 2, which is negative 4 over x squared. Just like we wrote. So that's done. Now, how about over here? Well, we'll keep the half. Why don't we take this 3x to the minus 1/2 and bring it to the bottom? So it'd be 1 over 3x to the positive half. And the derivative of this is easy. It's just 3. So all the derivative signs are gone. We're done the derivative, but we need to clean up this mess. Let's see what we can do here. The 1/2 I'll keep the same. This is just x to the half over 4 to the power of a half. What's 4 to the power of a half? Well, that's the same thing as root 4, and root 4 is just 2. And this stays still. Minus. Why don't I multiply the 3 over here so we'd have 3 halves? Let's get rid of these ugly brackets here. 1 over 3 to the half. I'm going to split it up. I'm going to write 3 to the half times x to the half. So what can we do now? Well, look here. 2 times 2 is 4. And we have a negative 4 on top. So it's like negative 4 over 4, which is negative 1. So we'll have negative x to the half over x squared. And over here, look what we have. We have 3 over 3 to the half. What is that? You know, this 3 is really a power of 1, right? So we can subtract those. 1 minus a half. We get this, right? Which is a half, which is root 3. So this over this becomes root 3. And then we have 2x to the half left over. So we're making some progress. This can be simplified as well. A half and like, why don't we think about bringing this x to the half to the bottom? It'll become x to the minus 1/2. And then 2 minus a half is 3 halves. So we'll have negative 1 over x to the 3 halves minus root 3 over 2x to the 1/2. Now, just like whenever we have a fraction problem, that 2 fractions are being subtracted, we need to get a common denominator. Why don't we multiply top and bottom of this one by 2? So we'll get negative 2 over 2x to the 3 halves. And this one I'm going to multiply top and bottom by x. So we'll get root 3 times x. And 2x to the half times x. What's x to the half times x? What's the reason I chose that? Well, this is power of 1. We add those exponents, we get the power of 3/2. And we've achieved our common denominator. So we can write this as -2 minus root 3x all over 2x to the 3/2. And I guess we could pull out the minus to the very front of the fraction to make it look a little bit nicer. And why don't we just bring the root 3x to the front and put this over here just to make it look a little bit better. And so that was a little bit tricky there. I hope that's okay. I think this is maybe the cleanest way to write our final answer. Let me just adjust that exponent a little bit, make it look a little bit better. And there we go. So I hope that one is okay.